Welcome to Women's Care USA's training on Claude, building your AI-powered clinical edge. Thank you all for being here today. Over the next hour, we're going to explore how artificial intelligence is transforming the way we work in healthcare operations, and more importantly, how you can harness this technology to make your daily work more efficient, more accurate, and more impactful. This isn't just another software training. What we're discussing today represents a fundamental shift in how healthcare organizations like ours can compete and deliver better patient care. Let's dive in. Let me start by answering the question you might be asking. Why now? Why is this training happening today? There are three critical realities we need to understand. First, artificial intelligence is transforming outpatient women's healthcare delivery models right now. Not in 5 years, not next year, right now. Healthcare organizations across the country are already using AI to optimize scheduling, reduce administrative burden, improve documentation quality, and deliver better patient outcomes. The transformation is happening whether we participate or not. Second, the first mover advantage window is closing rapidly. In any technological shift, there's a brief period where early adopters gain significant competitive advantages. They attract better talent, build deeper expertise, and create efficiencies that competitors struggle to match. We're in that window right now, but it won't stay open forever. Third, our competitors are already experimenting with AI tools. Some are doing it well, some are doing it poorly, but they're all doing it. The question isn't whether AI will be part of healthcare operations. The question is whether Women's Care USA will lead this transformation or follow behind. Here's what's important to understand. This technology augments clinical judgment. It doesn't replace it. We're not talking about AI making medical decisions. We're talking about AI handling time-consuming administrative and analytical tasks so our skilled professionals can focus on what they do best, taking care of patients. Let me break down what Claude actually does. First, it's an AI-powered command line tool for coding tasks. You don't need to be a programmer to use it. You can describe what you need in plain English, and Claude translates that into working code. Second, it understands medical workflows and healthcare data. This isn't a generic tool trying to learn healthcare. It already knows how healthcare data is structured, what HIPAA compliance means, and how clinical operations work. Third, it works in your development environment. This means it can read your files, create new files, and execute tasks just like a human developer would, but in minutes instead of hours. Fourth, it writes, debugs, and refactors codes autonomously. If there's an error, Claude can identify it and fix it. If code needs to be updated or improved, Claude can handle that too. Think of it this way. It's like having a senior developer on call 24/7. Someone who never gets tired, never forgets what you told them yesterday, and is always ready to help with your next project. Let me show you a comparison that really drives home why this matters. Traditional development means manual coding line by line. With Claude you can make requests in natural language. Traditional development means searching Stack Overflow for solutions when you get stuck. Claude provides context-aware suggestions based on your specific situation. Traditional development means reading through documentation for hours to understand how to use a library or tool. Claude autonomously completes entire tasks without you needing to understand the technical data. And here's the bottom line. Traditional development takes hours or even days per task. Claude takes minutes. That time difference isn't just about convenience. It's about what becomes possible when a task that used to take 2 hours now takes 3 minutes. Suddenly, analyses you never had time to run before become routine. Reports generated quarterly can be generated weekly or even daily. Data quality checks that happened once can happen continuously. The shift we're describing is from writing code to describing what you need. That's a fundamental change in how work gets done. Now let's get concrete. What does this actually look like in practice? Let me walk you through 4 real applications in clinical operations. First, patient data analysis. We can generate reports on visit patterns, outcomes, and demographics. Want to know how many new OB patients we saw last quarter, broken down by age group and referral source? That's a 3-minute task instead of a 2-hour task. Second, scheduling optimization. We can identify no-show patterns and optimize provider capacity. Which time slots have the highest no-show rates? Which providers are consistently over or underbooked? These insights can transform your scheduling efficiency. Third, documentation assistance. We can structure clinical notes and extract key information. If you need to pull specific data points from a set of clinical notes, Claude3 can do that systematically and accurately. Fourth, quality metrics automation. We can automate the tracking of clinical quality measures. Instead of manually pulling data for quality reports, you can automate the entire process and catch potential issues earlier. Each of these addresses a current manual, time-consuming task. These aren't theoretical use cases. These are the kinds of problems our staff deals with every single week. Let's look at the administrative side. There are 4 key applications here as well. First, billing code validation. We can check coding accuracy and identify billing issues before they become problems. We have the ability to catch potential denials earlier in the process. Secondly, insurance verification. We're able to automate eligibility checks and follow-ups. This is one of the most time-consuming administrative tasks, and it's highly automatable. Third, staff productivity analysis. Analyze workflows and identify efficiency opportunities. Where are the bottlenecks? What tasks are taking longer than they should? Data-driven insights lead to data-driven improvements. Fourth, compliance documentation. Generate required regulatory reports. Compliance reporting is critical but time-consuming. Automation ensures it gets done consistently and correctly. The focus here is on time savings and error reduction with measurable return on investment. When we talk about these use cases with leadership, we can point to specific hours saved and specific error rates reduced. All right, let's talk about how you'll actually use Claude in practice. There's a simple 4-step workflow that you'll follow every time. Step 1, describe. You tell Claude what you need in plain English. No special syntax, no programming jargon. Just describe the task like you would to a colleague. Step 2, analyze. Claude proposes an approach. It tells you what it plans to do and how it will accomplish the task. This is your chance to make sure Claude understood correctly. Step 3, approve. You review the proposed approach and give permission to proceed. This is critical. You stay in control. Claude doesn't execute anything without your explicit approval. Step 4, verify. Claude executes the task and you confirm the results. Always check the output before using it in production. This workflow is collaborative, not automatic. You're working together with Claude, not just pressing a button and hoping for the best. At every step, you maintain oversight and control. The quality of what you get from Claude depends heavily on how you ask for it. Let me show you 3 levels of prompt quality. Bad, make a report. This is too vague. Claude doesn't know what kind of report, what data to use, or what format you need. You'll probably get something, but it won't be what you wanted. Better, create a CSV report of patient visits by provider. Now we're getting somewhere. We specified the format, the data, and the grouping. This will produce a usable result. Best, create a CSV report of visits by provider, grouped by month, with total counts and no-show rates. This is what we're aiming for. It's specific about the format, the grouping, and exactly what metrics to include. This produces a professional, immediately usable output. The principle here is simple. Specific requests drive quality. The clearer and more detailed your request, the better the result. Think about what you would need to tell a human colleague to produce this work, and include all of that in the context of your prompt. Clarity is the most important skill you'll develop with Claude Code. Not programming, not technical knowledge, just the ability to describe clearly what you need. Claude Code gets smarter the more context you provide. There are four types of context that dramatically improve results. First, healthcare compliance requirements. Tell Claude Code about HIPAA regulations that apply to your work. Explain what data can and cannot be shared. The more Claude knows about compliance, the more it can help you stay compliant. Second, data structures and formats we use. Explain how data exports from your EHR are structured. Describe the format of billing files. Show Claude examples of the data you work with regularly. Third, business rules and workflows specific to our practice. How do we handle same-day appointments? What's our policy on overlapping appointments? What's considered a no-show versus a late cancellation? These business rules ensure Claude produces output that matches our actual operations. Fourth, expected output formats. Show Claude examples of reports you've created manually. Share screenshots of dashboards or charts you want to replicate. The more examples you provide, the better Claude can match your expectations. Here's the key principle. More context equals better performance. But remember, never share actual protected health information. Always use sample or synthetic data when teaching Claude about our work. Let's talk about working with files and data. The file workflow has four key steps. Step 1. Use sample or anonymized data only. This cannot be emphasized enough. Never, under any circumstances, use real patient data when working with Claude Code. Step 2. Common formats include CSV, JSON, and Excel. These are the standard data interchange formats you'll work with most often. Step 3. Claude reads, transforms, and generates files. It can read a CSV file, perform calculations, and output a formatted Excel report. It can combine data from multiple sources. It can restructure data into different formats. Step 4. Always validate outputs before production use. Just because Claude generated it doesn't mean it's perfect. Check the results, verify the calculations, and make sure everything makes sense before using it. And one more time, because it's that important, never use real patient data in Claude Code. Use synthetic data. Use test data. Use anonymized data. But never use real protected health information. One of the most powerful aspects of working with Claude Code is the ability to iterate and improve. Here's how the iterative improvement cycle works. First, Claude provides a first version. This might be 80% of what you need, or 60%, or even 95%, but it's rarely perfect on the first try. Second, you review and provide feedback. Be specific about what needs to change. Make it better isn't helpful. Add a column showing percentage change from last month is helpful. Third, Claude refines based on your input. It takes your feedback and produces an improved version. Fourth, repeat until you have an optimal result. Sometimes this takes 2 iterations, sometimes 5. That's normal and expected. Here's what's important to understand. Iteration is normal and expected. It's not a sign of failure. This is how collaboration works, whether with AI or with human colleagues. The first draft is rarely the final draft. The ability to quickly iterate is actually one of Claude Code's greatest strengths. Making a change and seeing results in seconds means you can explore different approaches and find the best solution much faster than traditional development. Now let's walk through a complete example from start to finish. We're going to create a provider productivity report. This is a real task that someone in operations might need to complete weekly or monthly. The input is a CSV file with anonymized patient data. It includes appointment dates, provider names, visit types, patient demographics, and whether the appointment resulted in a no-show. The output will be an Excel report with charts and analysis. Specifically, we want summary statistics, visual comparisons between providers, and a breakdown of visit types. Now here's the time comparison that matters. This task would take 1 to 2 hours if done manually. You don't need to open the CSV, import it into Excel, create pivot tables and generate charts, format everything and add calculations. It's all doable, but it's time consuming. With Claude Code, the same task takes 2 to 3 minutes. That's not a small improvement. That's a 95% time reduction. That's the difference between generating this report monthly versus getting it daily. That's the difference between I don't have time for that analysis and let me pull that data right now. Let's walk through how it works. First, we open a terminal and type Claude Code to start the assistant. Then we describe exactly what we need. Here's what we would say. Analyze the appointments sample.csv file and create an Excel report showing total appointments by provider, no-show rates by provider, and visit type distribution. Include a bar chart and a summary table. Notice what makes this a good prompt. It's specific about the input file name. It clearly states what metrics we want. It specifies the output format. It requests specific visualizations. There's no ambiguity about what we're asking for. This is the kind of clarity that produces great results. We're not saying make a report. We're describing exactly what we need in terms of anyone could understand. After we submit that request, Claude responds with its proposed approach. Here's what Claude would say. I'll analyze the appointment data and create a comprehensive Excel report. Here's my approach. First, I'll read and parse the CSV file. Second, I'll calculate provider statistics, including total visits and no-show rates. Third, I'll analyze the visit type distribution. Fourth, I'll create an Excel workbook with a summary statistics table, a bar chart for provider comparison, and a visit type breakdown chart. Proceeding with implementation. This is a critical moment in the workflow. Claude is telling us exactly what it plans to do before it does anything. This gives us the chance to say, wait, that's not quite right, or yes, that's perfect, go ahead. Notice that Claude breaks down the task before coding. It's not jumping straight into writing code. It's thinking through the problem systematically, just like a human developer would. This transparency builds trust and gives you control. You always know what Claude is doing and why. Now Claude goes to work. On screen, you'd see something like this. Creating provider report.py. Then you'd see the code being written. Importing pandas for data analysis, importing open.pyxl for Excel creation, importing the chart library for visualizations. Next, you'd see the execution messages, running analysis, reading appointments sample.csv, processing 40 appointments, generating statistics, and finally, successfully created provider underscore report.xlsx. The entire process from your original request to finished output takes 2 to 3 minutes. Let me emphasize that time comparison once again. With Claude Code, 2 to 3 minutes, done manually 1 to 2 hours. That's a transformation in what's possible. And here's what you get, provider report.xlsx. Opening that file, you'd see 3 key components. First, a summary table with provider statistics and professional formatting. Total appointments, no-show rates, average visit duration, all calculated and formatted automatically. Second, bar charts providing visual comparisons. You can immediately see which providers are busiest, which have the best show rates, and how the workload is distributed. Third, the output is professional and ready to present. You don't need to spend time making it look good. It's already formatted, properly labeled, and ready to share with leadership or to discuss in a team meeting. This combination of quality output, and 95% time savings is what makes this technology transformative. You're not choosing between fast and good, you're getting both. Now we need to talk about safety and security, starting with the most critical issue, patient privacy. This slide has a big warning symbol for a reason. Never upload protected health information to Claude. This is non-negotiable. There are no exceptions. There are no special circumstances where this becomes okay. Let me be absolutely clear about what this means. Use sample data or synthetic data only for training. If you need to practice or learn, create fake data or use the sample data sets we provided. Anonymize all data before analysis. If you need to analyze real patterns or trends, strip out all patient identifiers first. Follow organizational data handling policies. If you're not sure whether something is okay, just ask, don't guess. Privacy violations have serious legal and ethical consequences. We're talking about HIPAA violations, potential legal action, loss of patient trust, and damage to women's care's reputation. The consequences are severe, and they are not worth any amount of convenience. This isn't about being paranoid. This is about being professional and protecting our patients. If you have any doubt about whether data is safe to use, the answer is no. Beyond patient privacy, there are 4 secure development practices you need to follow. First, keep API keys secure. Never share your API key. Never commit it to version control if you're using Git. Never post it in Slack or email it to somebody. Your API key is like a password. Treat it with the same level of security. Second, review all generated code before deployment to production. Just because Claude wrote it doesn't mean it's perfect. Check that it does what you expected. Look for any potential issues. Make sure you understand what code is doing. Third, test in safe environments. Use development or staging environments before running anything in production. If something goes wrong, let it go wrong in a test environment where it can't affect real operations. Fourth, document AI-generated work. Make a note in your code or documentation that Claude Code was used. This helps with maintenance, troubleshooting, and compliance documentation. It's equally important to understand what Claude Code cannot do. There are 4 key limitations to keep in mind. First, AI can reflect biases in training data. Always review outputs for fairness and accuracy. If something seems off or problematic, trust your judgment. Second, medical decisions require human oversight. Clinical judgment cannot be delegated to AI, period. Claude Code is for administrative and analytical tasks, not for making clinical decisions. Third, Claude has no medical license or liability. You remain responsible for all outputs. If Claude generates something incorrect and you use it, that's your responsibility, not Claude's. Fourth, always validate medical adjacent outputs. If anything touches clinical care, quality measures, or regulatory compliance, double check it, triple check it. Have another person review it. The principle here is simple. AI is a tool, not a replacement for expertise or judgment. It can make you more efficient, but it doesn't replace your knowledge, your training, or your professional responsibility. Let's talk about transparency and disclosure. There are 4 contexts where AI disclosure matters. First, for internal documentation, always note AI assistance in code comments. Future you, or anyone else who works with this code, should know that Claude Code was involved. It helps with troubleshooting and maintenance. Second, for patient-facing situations, describe AI use in general terms if asked. You don't need to volunteer information unnecessarily, but if a patient asks how a report was generated or how data was analyzed, be honest that AI tools were used as part of the process. Third, for clinical decisions, outputs must have human review and approval. If any AI-generated analysis might influence patient care, Make sure a qualified clinician has reviewed and validated it. Fourth, for regulatory purposes, follow emerging CMS and ONC guidelines. This is an evolving area. Stay informed about regulatory requirements for AI disclosure in healthcare settings. Transparency builds trust with patient and regulators. We're not trying to hide our use of AI. We're using it responsibly and being open about how it fits into our operations. Before using Claude Code for any task, verify 5 things. 1. Task involves no real patient data. If there's any PHI involved, stop. Anonymize it first, or use synthetic data. 2. Output will be reviewed by qualified staff. Someone with the appropriate knowledge and authority needs to check the work. 3. Fits within organizational AI policy. Make sure what you're doing is approved and appropriate. 4. You understand what Claude is doing. If you can't explain the approach or logic, you need to ask questions until you do understand it. 5. You can explain the approach to others. If someone asks, how did you generate this report, can you explain it clearly? If not, you need to understand it better before using it. This checklist is designed to be printed and kept visible at your workspace. Make it a habit to mentally run through these 5 points before starting any Claude Code task. Alright, we've covered what Claude Code is, how it works, and how to use it safely. Now let's talk about your path forward. We're recommending a 3-phase rollout. Phase 1, weeks 1 and 2. Install Claude Code on your computer. Complete the practice tasks we provided. Attend the first office hours section where we'll help with any installation issues and answer questions. Phase 2, weeks 3 and 4. Start working on small projects with peer review. Complete the intermediate practice exercises. Share your early wins with the team. This is where you build confidence and start seeing real value. Phase 3, month 2 and beyond. Full integration into your daily workflows. Automate 1 or 2 manual tasks that you do regularly. Begin mentoring colleagues who are just getting started. The key principle here, start small, build confidence, then scale up. Don't try to automate your entire job on day 1. Pick one annoying task that takes 30 minutes each week and automate that. Once you've succeeded with one task, move on to the next. You won't be doing this alone. We've set up multiple support resources. First, we have an internal champion, me. I'm someone who knows Claude Code well and is designated as your go-to person for questions. My contact information is on the slide and will be in the materials we send you. Second, we have complete documentation at docs.anthropic.com. This includes detailed technical guides, examples, and troubleshooting resources. Third, we maintain practice datasets on our internal SharePoint. You can access sample data that's safe for use for learning and testing. Fourth, we're running weekly office hours. This is live help and demonstrations. Bring your questions, bring your challenges, and we'll work through them together. The important message here, questions are expected and encouraged. We're all learning together. If something's confusing, if something's not working, if you're not sure how to approach a problem, just ask. That's what these resources are for. We're going to track the impact of Claude Code adoption in 4 key areas. First, time saved, both per task and in aggregate. We want to know how much time individuals are saving and what total impacts are across the organization. Second, error reduction in data processing. Are we catching more problems earlier? Are we making fewer mistakes in our reports and analyses? Third, the number of workflows created and automated. How many tasks have we successfully automated? What's the cumulative effect? Fourth, team confidence and capability. Are people feeling more confident with the data? Are they taking on analytical tasks that they would have avoided before? We'll be tracking these metrics quarterly. This helps us demonstrate return on investment to leadership, identify what's working well, and adjust our approach where needed. The goal isn't to use metrics to judge anyone. The goal is to understand, impact, and continuously improve. Let me close by coming back to the big picture. We're pursuing first mover advantage in AI adoption. But what does that really mean? It means we're not just adopting a tool, we're building organizational capability. 4 specific advantages we're aiming for. First, build a competitive advantage through AI capabilities. Become known as the practice that uses technology effectively to deliver better care. Second, attract and retain top talent. The best people want to work at places that invest in their skills and give them powerful tools. Third, deliver better patient experiences. When we spend less time on paperwork and data processing, we have more time for patients. Fourth, establish innovation leadership in women's healthcare. Position Women's Care USA as a forward-thinking organization that leads rather than follows. This is about building the future of our organization, and that future starts with each of you learning and using these tools. Ready to get started? Let's build the future together.